All right, everybody, let's get going on this. Let's see. Open up my window so you can see everybody. So today, business as usual, right? I'm going to be jumping into this. And so first things first, as always, we're going to be opening up our annotate tool and drawing all over these slides just to kind of get warmed up, right? Get ready to be involved. So if you would, go ahead and, if you have the ability to, turn on your cameras and go ahead and start your annotate tool and start drawing all over the place. I'll make things anonymous so that the hide names of annotators so that drawing stuff on my slides doesn't pop your name up. And let's get it out of our system, right? Start marking up all over the place. So today we're going to be jumping into our fifth workshop out of 6, right? So we're nearly there. And then at the very end, we will have yet another opportunity to take the test if you so wish. So 5, 4, 3, 2, 1, let's finish up with that doodling, right? And we'll get going here, okay? So let's see. Today, we are going to be, let's see, moving into week 5. So mirrors, reflection, and cross sections. So let's start here. So mirrors and cross sections, right? We've kind of got 2 different subjects to cover today. I would say that the skills that we're going to use in terms of drawing, right, the really hard stuff is these are things that we've practiced before, right? So I won't belabor the idea of, you know, drawing isometric things, right, too much, right? But that's really the basis for where we're building off, right? So if you're feeling uncomfortable with that whole process still, I would encourage you to go back to the inclined planes and curved surfaces workshop, and or all the way back to the isometric drawing workshop, right? But for now, right, let's focus on the first half of this lesson, which is mirrors and reflections. Right? So drawing a reflection of a part. When we do that, what do we need in order to define how we are reflecting our part? Right? When you look in the mirror, how would you describe the shape of a mirror? It can be round, it can be rectangular, but we know that the thing that's similar about them is that they are, I'm not practicing my miming.
Reflection.
Yeah, okay. They are a reflection and they are flat, right? They are planar, right? And so we need a plane to define what we are reflecting about, right? A line doesn't necessarily give us enough information on how we are reflecting something, right? Similarly, neither does a point, right? But a plane will give us enough information about where, you know, we are making this reflection. And so let's use some of these tips and tricks to kind of go through this once, and then we'll practice it together here in just a minute. So if this is my plane, my reflection plane, we can argue that the kind of the orientation of this thing mimics the orientation of, say, this face, right? These rectangles kind of look the same, but they're scaled at different sizes. Right? So what's the deal with this? Right? Well, the whole plan on this front, right? The whole strategy for doing something like this is to plot all of the vertices, right? All of the points, all of the corners of our original part as they would appear across the mirror, right? And so, right, most of the time when we think about mirrors, right, what's the first thing that you think about when you think of what happens left and right in a mirror? What happens when you look at when you're looking in a mirror? What switches? What do you think?
Left and right.
Right, left and right switch places, right? It looks like things are backwards when we look at them in a mirror. The thing is that it's not actually quite that way, right? It appears backwards, but actually there is a one-to-one relationship between how things are reflected, right? It's not that things are crossed, right? The light traveling from us and to our eyes isn't crossed backwards, right? It's actually that it's reflected exactly as we would be seeing it from our own perspective, right? So this idea of things being backwards isn't so much it's not necessarily the most rigorous way of describing it, right? So let's I want to dissuade you from that idea at least, and so let's actually go through this rigorously, right? So let's start with these 4 points, right? The 4 points that make up the face that is nearest to the face of the plane. Now, if I project these points out to the point where they actually intersect the plane, right, at these little X's, you start to kind of see where in space I'm talking about, right? This plane that was drawn originally is maybe a little bit hard to see exactly where it lives forward and backwards, right, without some context. But now that I have drawn the legs out of these dots, right, projected directly towards normal to this reflection plane, you can kind of start to tell where this plane is in space, right? So if I were to continue these lines, the same amount of distance from the plane to the part as I originally had, but on the other side, right, projecting them out to here, these are my, we call them prime, right, like as in Optimus Prime or, you know, whatever. It's the prime plane is the reflection, right? It's the same thing, it's the same object, but in the prime dimension, it means that it's been augmented in some way, right? It's related, but slightly different. So these red points, red, yellow, gray, and blue points are the prime points reflected across this this plane, right? Can we all agree on that? So from here, what do I need to do? Well, I can start kind of drawing some of my edges, and I might be interested in doing something like that, right? I can kind of draw one of these solid lines, right? But I need to be careful about which ones I draw first, right? Or which lines I make solid. This is the same thing that we went over in the very first isometric drawings lesson, right? Where it's like this line, this kind of dotted line shape right here, right? Let's see, where's my tool, right? This corner, which is a reflection of this right here, is going to be hidden once we project our part like this, right? So, and maybe you see that, maybe you don't, but let's keep going with this. We just, remember, need to be careful about how we are drawing our isometric views. So real quick, folks, if you'll help me out with the annotation tool, right? We've got 1, 2, 3, 4, 5, 6 spots, six plot points on our view right now, right? That we need to project across this mirror plane, right? And so you saw that the first ones, right? You saw that the first ones kind of followed along these projection lines, right? So if these were the first 4 dots, they were projected across to this these spots along these projection lines, right? And so all of these other spots, the orange, green, purple, maroon, actually I guess it's dark gray, pink, and white dots, those are going to follow the same projection line. So now that I've rambled on enough, right? If you'll go ahead and help me with your annotation tool, draw where these dots are going to live, right? If you want to change your colors, that's fine, right? Just so that I know exactly what you're talking about. But good, we've got a green dot. I'll start to kind of guess, convert them, right? Trace over them, right? So this green dot is in reference to this green dot, right? We can see that this kind of line that projected out from here follows back one unit, one block unit from this point, right? So this is 1 unit. So this is 1 unit. Our green dot is right there. Looking good. We've got a lot of really great drawings so far. We've got the purple dot down here. Very good. Thank you for even drawing the, you're even drawing the dotted line. That's very good, right? Got our orange dot up here, right? And so I'm going to start drawing the line that the lines that connect this thing, right? With maybe dark green. How about that? So this line between the green and the purple is going to come up like this, right? This line up here that comes from the front, right, is going to look like this. This line right here. We can keep going like this. And then we move back to the pink dot. Move down to the purple. This one right here. And then move up to the front. And let's see, what else do we have? Well, there's this dot, right? But this dot is projected like this. Where does it eventually go? Let me trace over this one too. What points are we missing? Because we've got everything else. Ah, very good. So this corner right here was hidden originally, right? It's kind of back behind this in here, right? But we can infer that, you know, based on the reflection, we can kind of make this corner right here. Right? And then similarly back here, right, we had this kind of hidden square face. Right? So let me see if we got it all right. I'm going to clear our drawings, right? And hey, there we go, right? We've got this reflection of our original shape, right? Now, you may argue or notice, right, that is the original shape different from the shape that we've just created? Is this shape different from this shape?
Yes.
Or, okay, so in what way? Let's see. It's been reflected across, right? But is there a rotation, right? A rotation that could have been implemented to get our shape from this to this? Do you see what that rotation could have been? If you were to rotate along this line, right? 180 degrees across like this, right? Would you agree that we would get the same thing, right? This top face ends up being on the bottom. This front face also stays on the front, similarly here, right? So in this case, this part didn't really change fundamentally, but it did, you know, it changed its position, right? It changed its orientation. Okay, interesting, but let's see if that holds true with everything. Right? And I'll invite you, I'll give you this prompt, this question first, right? What do you think differentiates shapes that are reflected and maintain kind of their shape, right? They don't turn into brand new shapes, fundamentally different shapes, versus shapes that can be reflected and maintain their fundamental shape, right? What is the difference there? And let's play around with that, right? So, well, okay, I guess the title of my slides and the labels here kind of give away the punchline there, but let's look at it, right? If we were to reflect this shape, which happens to be a symmetric shape, right? What is it symmetric? How is it symmetric? Well, it's not top-bottom symmetric. It's not front-back symmetric. It is left-right symmetric, right? If we look at it, if we cut it down the middle let's see, along this dotted line, which I'm about to draw right now, right? That dotted line, we have a symmetric, you know, we have symmetry, right? Those two shapes are the same. So if we reflect it across that shape, right, across this plane, what do we get? Well, we actually get the exact same thing. Now, similarly, if we were to have reflected it across, say, I'm going to try my best here to create a plane that looks about right. Let's say that our plane was kind of in front of this thing, right? Such that we're facing this way across this plane, right? The reflection would result in this kind of shoebox facing this way, right? Oops, this way now, right? And so that is more of a rotation than anything. The transition from this one to this one was effectively nothing, right? It was reflected, that didn't make any effect, and the effective rotation really would have been 0 degrees in no direction, right? But to get from here to, let's say, right, it would kind of look like this. Oof, this is rough. All right. Our shape would kind of turn around like this. In order to get from here to there, we would actually rotate 180 degrees about, say, a vertical axis, right? Well, okay, I won't belabor this point too much, right? But you know, to look at an asymmetric object, right? Something that has no symmetry involved in it, right? When we reflect that across this plane, right? Oh, hey, look, same object. When we reflect this across the plane, you'll notice that there is no way that we could rotate this shape such that we get this shape. Would you agree? There is a specific way that we can rotate this one in order to get here. Well, it's 0, right? It just so happens to be. But something like this, there is no way. This is a completely different shape than what this is, right? They have similar features. They, you know, kind of look the same. But this, in this case, the reflection is, it results in a shape that is completely new, right? So again, this is why I label this a trick rather than a tip or, you know, an instruction, right? It's not really necessary for us to memorize whether or not it's asymmetric or symmetric. This is just happens to be a property, right, that we might be interested in. But again, this whole idea of taking these, you know, these points, right, say this one, this one, this one, and this one, and this one, right, and mapping them across this plane, across the straight lines that are normal, the normal lines to this plane, this reflection plane. Let's see, where's my line tool? Right? Something like this is how we actually generate these reflections, right? So you'll get plenty of practice with that. In fact, do we have one? Yeah, okay, here we go. One more practice, right, a thing. And here's one thing that I will suggest is that usually it's easiest, right, when we're drawing isometric views, what was the tip that I suggested? Which point, which corner, which vertex do we start with in order to draw our shapes more easily without having to erase? If I were to tell you, what's it? Yeah, the closest one. Thank you, don't you? Right? Exactly. So in this case, I would say that maybe, you know, this corner or this corner would be a good place to start if I was drawing this shape by itself, right? However, I'm not drawing this shape. I'm drawing the reflection of this shape, right? And so effectively, when this thing, you kind of have to have a little bit of foresight into what's going on, right? But effectively, the points that get reflected off of this corner are going to, right, they're going to be right here. I'll give you this one, right? And those end up being the closest points to our new reflected view, right? And so I would suggest figuring out what are going to be the closest points in our new view, and then starting from those points in our original view, right? So in this case, the part doesn't, you know, start here, but we'll keep going. So it looked like somebody started drawing. I would encourage you to continue on with that, right? Thank you for starting. Looks very good, right? So I'm gonna kind of mimic what y'all are doing. Let's get a lot of involvement here from everybody. Go ahead and pick up those annotation tools and let's start drawing these points, right? I'm just gonna kind of start filling in the gaps, right, with lines and whatnot, while you all do this, right? And Do your best, right? Even if you're not quite sure, throw a line up there. And if you're right, then that's great. If you're wrong, then it gives us something to talk about, right? I encourage you to be involved with this, right? So let's see. Right now we've got these lines, right? Okay, very good. Got these parts right here, right? Some of these lines, right, like this one and this one, are not visible in the original part. But okay, so here we go. We've got this line, this vertical line now. Right? We can kind of work our way down this stair step. Good. It's hard to keep up with y'all when there's so many of you drawing at the same time, right? Okay, so here we go. We're nearly there. We're pretty close, right? I would say that this is the current state of our part, right? So this line just got drawn. Is there a suggestion that's what do you think about this line, right? We're getting a little bit wacky over here, right? Okay, so we've got this. Okay, what do we think? I'm going to take a minute and let y'all think about it, right? So if I drew this line, right, that would be right here, but there's no edge right there, right? So this line needs to go away. Okay, so right, we have kind of an overlap with an existing line, right? This line and this line, that's good, right? We have this, and so therefore the remaining edge right here needs to go where? There you go, very good. So we got that. Let me draw over it in our normal blue color. Very good. And now we have this line right here, which goes over here. And are we done? I think so. Looks like it. Right? There are a lot of edges that didn't get traced over, right? But again, that's fine. We are effectively seeing a new shape. Now, let me ask you this, right? Pop quiz. Is this shape a new shape? And why do you think so? Could we rotate the original shape in any way to get our new shape? I'm seeing Ella shake her head no, right? And the reason that you see that, other than, you know, maybe you're seeing it and it's like, no, there's no way to do it, right? What is the main reason? What is the geometric reason that we can't do that?
It's not symmetric about any axis.
It's not symmetric, right? It's not symmetric about any planes, right? Very good. Okay, so there we go. We got this one. That's one lesson down. Let's see. I'm gonna check and see if we did it right. Looks good to me. Sweet. Okay, here is the second stage in our lesson 5 workshop, right? Kind of ramping up the speed here to cover more material, right? And that is cross sections, right? Again, you'll realize that the test that I'm asking you to take, right, this PSVT, is a rotations test, right? It's not a reflections test. It's not a mirrors test. It's not a cross sections test. It's a rotations test. So, right, these skills that we're learning right now in this lesson specifically are more kind of rotations adjacent, right? Just like learning how to draw isometric views wasn't part of the test, but it was helpful for us to learn how to, you know, kind of work our way through this. These topics are adjacent, right? But they're also really useful. And so I start this one off, this cross sections off, with a bit of an analogy, right? Why do we care? So why do we care? Well, so I've got 2 screws here up on the screen, right? I've got this cap head screw, which has a cylindrical head, and a countersunk screw, right, which has this kind of conical shape up at the top, right? These 2 different screws are typically drilled into a part, right? And they can be sunk in such that the heads of these parts are made flush with that they're going into, and those extra holes are made by these tools. This is called a counter. I can't remember which one is which. Actually, I always forget. I think this one is a countersink. A countersink, right? It's more cylindrical, and this one is a counter bore, right? It makes a tapered kind of hole. The whole idea behind this, right, is that we've got our conical shape and our cylindrical shape, right? If we were to drill a counter bore into this thing, or a countersink into these things, such that the end result means that the tops of these screws, right? Let's see, where's my tool? The tops of these screws are flush. Very good. Hey, somebody's jumping ahead. This is fantastic, right? The tops of these screws are flush like this, right? But really, we can't see them, right? So the only way that you could possibly describe using a drawing like this, the shape of the profile of what this looks like without giving a description, hey, this is a countersink, right? Or whatever, or this is a counter bore. The only way to see this is through cross sections. And so just like somebody else was starting to draw, right? Let me use my slide animations here, right? If this was the cross section plane, which cut our original block in half like this, right? The profile that we would end up with would look something like this. Would you agree? Right? From the side, the screw, right? This cap head screw would fit down in here such that it is, flush with the top, and the threads come down in here. Similarly, for the tapered screw, right? We kind of have this channel that's cut through, and the threads come down here. Right? Again, we wouldn't be able to see the fact that any difference between this or this, right? These are both legitimate top views, right? But and from the side, we wouldn't have been able to see it. But now we can actually take a look inside by taking a cross section, right? Here is a reason why you should care, right? But let's actually talk about how we would go about doing a problem that you might find in the exercises for this lesson, right? So taking a cross section of something like this, right? We can talk about, the top plane or the front plane or the right plane, the kind of the basic geometric planes that we usually talk about, right? And that's fine. That's kind of what we just talked about with the cross section, right? Or I'm sorry, with the screws in the last one, right? This is kind of a pretty fundamental plane, right? It cuts it straight down the middle of this part. But perhaps a more challenging, more interesting way of doing this in exercise is this, right? What if this was our plane, our cross-section plane? It's an angled plane that cuts through our part at this kind of angle, right? If you see that the yellow dotted line is kind of where the green plane actually intersects with our part, right? Then these dotted lines are effectively what we need to transition over to this grid, right? And so how do we do that? Well, again, we're gonna have some practice here together here in just a minute, but let me walk us through one just so that everybody's on the same page, and then we'll do it together, right? So the first thing that we can do, that we notice, is that we need to project a new kind of offset grid into our new section plane, right? You'll see that if I put this grid, which isn't really the isometric grid, it's not the orthographic grid. In this view, it's kind of this weird in-between grid that I've projected along this thing, right? And I have these kind of in-between markers that help us visualize how this thing is laid out, right? It's kind of at an angle, and these points are distributed like this, right? If I were to transition this over here, let's see, I'm going to mark this point. Right? This is a corner. This is an interesting point. This is an interesting point. This one and this one. How would I move those over here? Well, let's see. I'm going to move them, right? I can see that this is 1, 2, 3 across, and 1, 2, 3, 4, 5 down across this diagonal, right? And I can project that here. The interesting thing is, right, I would argue that this original shape is more like a cube, right? It's 1, 2, 3 by 1, 2, 3 by 1, 2, 3. But now this projection looks like a 3 by 5 rectangle. So taking a cross section of this kind of weird angle is going to distort our view, right? It's going to kind of stretch certain dimensions out, and it's going to keep some the same, right? It's going to remain 3 wide here, right? 1, 2, 3. Wait, did I do that wrong? 1, 2, 3. 1, 2, 3, 4. Wow, I did it wrong. Okay, that's great. Anyway, this you get the idea, right? I'll fix that later. I guess. But you know, this projection into this kind of longer shape gives us this. We know, and we also need to be concerned about this circular shape in here, right? You'll notice that the oval, right, the circle shape on this face, which we could argue is a circle, right, is now an oval that are stretched along that axis that is tipped back, right? Okay, so let's actually practice this together. Let's say that this is my shape and I want to project, I want to take this cross-section plane in multiple places, right, and project it over here. Now, the first thing is that, right, just this alone doesn't quite give us enough information to tell us where front and back this thing is, right? So let me give you a marker right here, right? If this plane, right, is moved front and back such that it intersects multiple places, but one of the places is this corner right here, what would the shape of the cross section be? Well, let me again, because this is still a little bit of a kind of a exposition on how we're going to do this, right? Let me show you how the yellow one works. Right? I'm going to project this kind of cut line out here along these kind of inclined planes so that these cut lines are projected along this face, right? And therefore, the shape that I would be left with, right, arguably most of these lines, right, are hidden behind here, right? Right? Something like that, right? When we project it over here in this cross section, we get something like this, right? Okay, so if that's the case for the yellow one, right, let's try this blue one, right? Mark some of the other points on the cross-section plane, right? That putting the plane on this vertex would also intersect with, right? Does that make sense? That's kind of a roundabout way of saying this, right? But since this is symmetric about this face, hey, look at that, beautiful, right? So this blue corner would also be part of the, part of the cross section, right? So let's map those over here. If I'll put one of them right here. I have no idea how my slides will actually progress, so we'll see if I got them about right. Look, somebody else drew something right here, right? That's perfect. Let's draw it a little bit bigger. You could argue that everything along this line is going to be projected, right? So there's some points right here. And then, so how does everything else work, right? I'm going to kind of set the stage right here while we think about it some, right? I'm going to put a dot right here, and then maybe a dot right here, and a dot right here, right? For these blue dots. Everything else is going to be you. I'm going to stop drawing, right? Or at least we'll see. I think that y'all are seeing what I'm getting at, right? This one's kind of hard to see. What lines could we draw? You saw that earlier when I was drawing my yellow lines from here, right? I kind of drew this line, these dotted lines that cut through my shape. What would these blue ones look like, right? If you were to use a blue tool, right? What would those dotted lines look like? What do you think? Okay, very interesting, right? Okay, very good. So somebody's drawn a blue line right here. I'll draw it over here since this is a symmetric thing, right? You'll notice that since this face, these faces are vertical, right? Then the lines that are cut through this this plane are going to, right? They're going to kind of go straight up this wall. Oops, I'm doing a terrible job of drawing a straight line. Right? Here we go, right? And similarly, right, for this one, I'm going to just kind of make this a little bit straighter so that it's very, very clear, right, up to here. Okay, very good. Now, what else? What else is our intersection, right? So we have kind of this empty space, which is not going to be crossed. And then where else do we have intersections? Well, just like these yellow lines, right? I would argue that if we were to take these yellow dotted lines, right? Let's see if I can do this, and move them down here, right? This is the same line that we would travel with our blue line, right? Since it's on the same kind of face, the same angle of this face, right? So this would be one of the lines, and therefore this would be one of the lines, right? Very good. Somebody was starting to draw it. I appreciate that. So what do we need to do over here in order to take this right into here? Somebody start helping me draw right there. What are these cross sections going to look like? Ah, very good. Okay, so from these inner corners, right, we have some vertical lines. Right? Nice, very good. Look at all those colors drawn across, right? We're gonna make these two separated triangles, right? And this is really it. This is our cross section along the blue position of this plane, right? So I think I got ahead of myself here. Let's see. Oh, yeah, there we go. Here's the blue. And so the cross section looks like that, something like that. Very good. Lastly, how about this red point? Where does that, where are some other intersection points, and how does the end result look when projected over there? I saw a blue spot show up over there. That was good. It was pretty close, I would say. So you'll notice that, and this is a little bit pedantic. Maybe I should make this a little bit more clear, right? I'm not exactly on this corner, but you know, close enough, right? I'm kind of on the edge, right? There you go, right? So there's that purple line, right? And so where is the dotted line that I'm going to draw that actually shows the cut line across the physical part that I have? It's going to be pretty minuscule. Yeah, right? Exactly. So it's this dotted line across this back top, the top of this edge, right? And that's really it. Everything else is kind of behind it, right? And we can't see those, right? So I'm not going to actually draw those dotted lines, but you get the idea. Right? So what does the actual projection of that look like with the red dot, the red dots? What do you think? What is the overall shape of this cross section going to look like? How about if I draw this up here? Right, let me get you started. If this goes like that, right, across here, there's kind of this top edge like this. Right? Those back faces are vertical, right? And so what happened with these vertical edges, right? What were those? In the blues, those ended up being kind of those vertical edges, right? There we go. Good. No, somebody started drawing them, and that was the right answer. Right? So go ahead and place those back in there. We have these vertical edges. Right? Good. And then on the back, assuming that the bottom of this thing is flat, right, we have, again, just a rectangle. Right? So finishing that up with our slide animations. Right? There you go. Nothing particularly interesting on this one, but again, right, different cross sections at different depths are going to generate different kind of patterns, right? You can think of it kind of like an MRI, right? Something that, you know, you scan through your brain and you're getting shaves, these kind of layers of your brain, of your body, of your head, whatever you're scanning through an MRI, right? This kind of same effect is achieved when we kind of move this plane back and forth, right? And that's it, okay? So I'll let you at it, right? The assignment and the slides have been posted onto Canvas, right? I'm gonna take this workshop that I've recorded tonight. Once it's processed, I'm gonna post it onto Canvas and we'll be all set, okay? Again, business as usual, just looking for an hour of your time practicing the different assignments that I have, or the different activities that I have on the assignment, and then some evidence, some screenshots, some pictures with your phone, whatever it may be, right, showing that you have done that, posted to the Canvas course, okay? Does anybody have any questions about how things have been going, whether it be the content of the workshops or the way that the SV tested, you know, the retest or whatever? How are we feeling? Any questions or ambiguity that I need to clarify for you?
I have a question.
Yeah, what's up, Nathan?
So if we take the retest and we get above a 20 or the target score, do we still need to finish this workshop, or are we done once we hit that score?
Once you've hit that score, you are good to go. However, so here's the thing, right? In order for your test score to be eligible, you have to have taken all of the workshops up to that test, right? So this most recent test that we just did, right, which was the first retest, that requires you to have shown attendance for workshops 1, 2, and 3, right? Whether or not you were actually here, right, there's fine. We have absent makeups, right? Just talk to me. It's not a big deal. But having done all of the work, done the assignments, right, that's 3 hours of your time over the period of 3 weeks. And then taking the test. If you successfully finished that and got got a 20 out of 30 or greater, then you get your 5% of your test. But you may as well stick around, because if you continue through this, right, and we're pretty much nearly through the entire workshop, right? If you finish and attend all of the workshops, right, then you also get an extra 3% extra credit on top of all of that, right, of your final grade. So, this is my way. I have a few folks who, from the very beginning, got a passing score, and they're still here because they want that extra credit, right? So it's kind of what you put into it. I want to, you're doing extra work, and so I want to pay you for it, right? I can't pay you as an employee, but I can pay you as a student, which means I give you extra credit, right? And points where they are deserved. So those are kind of the reasons why you might continue taking this workshop. But yes, to answer your question more concisely, if you have finished and you've scored at any point 20 out of 30 or greater, then you have that 5% of your grades. What happens to don't pass all?
Great, thank you.
Yeah. So there's a good question up here, right? What happens to those that don't pass all 3 tests ever, right? So let's say you took the first one, you didn't pass. You took the second one, you didn't pass. You took the third one, you didn't pass. Well, that if you took the third one and you still didn't pass, that means you did take all of the workshops up to it. So you get 3% extra credit, which kind of subsidizes the fact that you didn't quite get that 5% of your grade, right? So 5% of your grade is what this test is for, right? There are situations where you could take all of these workshops and not, get a passing grade in the test, but you get that 3% extra credit to kind of subsidize, to kind of pad that vacuum in your grade, I guess you could say, right? So if you don't pass the test and you don't take the workshops, right, then you're missing out on 5% of your grade, and you don't get the 3% extra credit. If you do everything and you pass and you get, and you've attended everything, then you effectively get that 5% plus an extra 3 on top, right? So there's, and everywhere in between, right? So again, I wanted to, I would hate to have y'all go through this entire thing and still not get the test points, and then you're like, well, what did I spend all that time for, right? Hopefully there is some sentiment that, hey, you did learn a new skill, right? And while it's difficult, it requires some practice, you still learned a new skill, right? But I want to pay you what I can, which is an extra credit, right? So I negotiated with your professors that 3% extra credit, right, is kind of a hey, thanks for doing the work, regardless of what the outcome was on the end, right? So, does that make sense? I know that it's kind of there's a lot of rules and regulations about this. That's what I get for being an extracurricular workshop, right? I'm not an actual course. So, gotta mesh into everybody else's classes. So, alrighty. Well, thank you, everybody. It's about that time. It's actually right on the nose. So yeah, thank you all for coming and interacting, and we'll see y'all later. Okay.
Mo, I have a question about like last week's stuff.
Yeah. What's up?
Thank you.
So on the I don't know what it's called. Wait, workout.
Uh-huh.
I don't know if you can pull that up, but
let me have you. Do you have it opened up right now?
Yeah, I'll get your screen, I guess.
Yeah, that's great.
Can you see that?
Yep.
Okay.
Cool.
So I was under the impression that this right here is not the front view and it's the side view.
Okay. Yes.
Is that correct?
Yes. Yes.
Okay, because
So
it
this,
just says that it's going to give the top and the front view, and the
okay.
rest of them do. But then yeah.
Interesting. Yeah, no, that's a good point, right? So this one, it looks like they gave, I mean, really, if you want to get pedantic, right? The front view is, pretty arbitrary, right? If this is the top view, or rather, if this is the top view, then this could be the front view for all you care, right? But then that means that this would be, instead of the right view, it would be, let's see, it'd be the left view, right? So let's see. No, I guess it would still be the right view, right? Because this is the correct answer. Is that right?
Um.
I think so.
So
right?
that's like so that's viewing it from the back side of
Right.
that. Okay.
So this is, let's see. So the
Sorry.
blue one. Let's see. The blue one right here is from this side, and the yellow one right here is from the top, right? So yeah, it's just been shifted, right? And that's
Okay.
kind of a rotten way to go about it, I would argue, right? I would agree. This is different than how, say, like you said, this one is. But yes, you got the right idea. It's not consistent with how number 3 was presented, but it is, it is the right view if this is the front view, right? So yeah,
Okay, that makes sense. All right. Thank you.
yeah, no problem. All righty. We'll see ya.
Yes. Yeah.